Students, in this video we are going to discuss about rules for determining the uncertain in the result of arithmetic calculations. Once again I am repeating the point, rules for determining the uncertain in the result of arithmetic calculations. Now go for point number 1. Point number 1. If the length and breadth the length and breadth BREADTH. Once again, if the length and breadth of a thin rectangular sheet are measured using meter scale. As 16.2 centimeters and 10.1 centimeters. Once again I am repeating, if the length and breadth of a thin rectangular sheet are measured using meter scale as 16.2 centimeters and 10.1 centimeters. Now there are three significant figures. There are three significant figures in each measurement. It means the length L may be written as L is equal 16.2 plus or minus 0.1 centimeters. Once again I am repeating this point, my dear students. If the length and breadth of a thin rectangular sheet are measured using meter scale as 16.2 centimeters and 10 centimeters, there are three significant figures in each measurement. It means the length L may be written as this one. Now, as well as the breadth as B is equal to how much? 10.1 plus or minus 0.1 centimeters, because its precision is 0.1. it also 0.1. So this is also like that only. Therefore, L is equal 16.2 plus or minus 0.1 centimeters, and percentage error percentage length is equal 0.1 whole by 16.2 into 100, that is equal how much? 16.2 plus or minus 0.6%. Similarly, birth B is equal how much? 10.1 plus or minus 0.1 centimeters. Therefore, percentage error percentage birth. Therefore, the percentage birth is equal to 0.1 whole by 10.1 into 100. That is equal, we will get 10.1 plus or minus 1%. Now, therefore, L into B is equal how much? 163.62 centimeter square plus or minus how much? 1.6%. Now, therefore, percentage error is equal delta A mean by whole by A mean, that into 100. Tell me, what is the percentage error? That is 1.6 is equal delta A whole by 163.62 into 100. Now tell me 1.6, this one 1.6 is equal to delta A mean by, what is A mean? 163.62 into 100. Now delta A is equal to 1.6 into 163.62 whole by 100, that is equal to 2.61. This is one method. Now go for second method. Now L into B is equal to Z. We know. Therefore, delta L by L into delta B by B is equal to delta Z by Z. Now, what is delta L? 0.1 whole by 16.2 plus 0.1 whole by 10.1 is equal to delta Z whole by 163.62. Whenever we are multiplying with L into B, how much? L into B is equal, we will get 163.62 centimeter square. So that one I wrote here. Therefore, so what we will get here? Here 16.2 into 10.1. Here how much we will get? 0.1 into 10.1 plus 0.1 into 16.2 is equal delta Z whole by 163.62. Now tell me, delta Z is equal to how much we will get? 1.01 plus 1.62 whole by 163.63. That is equal, that implies delta Z is equal to 2.63. That means delta Z by 163.62. Delta Z by 163.63 is equal 1.01 plus 1.62 whole by 163. That is equal, how much we will get? Delta Z is equal 2.63. This is another method. So among these two methods, we will get same significance number. Now go for point number 2. Now point number 2. If a set of experimental data is specified to n. N means infinity number. N significant. N significant figure. N significant figures. A result obtained by combining the data will also be valid to n significant figure. Once again I am repeating the students. If point number 2, if a set of experimental data is specified to n significant figures, a result obtained by the combining the data will also be valid to n significant figures. Suppose it is light velocity 2.99 into 10 to the power of 8 means significant is n. Similarly, the result also n. Now, if A. Data are subtracted. If a data are subtracted, the number of significant significant figure can be reduced. I would like to give one example to make you understand easily. That is, now I want to take 2.9 grams and also 07.06 grams. Now I want to reduce. Now what is the answer? Here is 4, here is 8, here is 5. Now grams. Now please observe carefully. Here we may rewrite this one as 5.8 grams. Once again come to for this one, if a data are subtracted, the number of significant figure can be reduced. That means this value is reduced from this one. As a result, we may rewrite as 5.8 grams. But remember, only 5.84 grams is uncertain. Uncertainties in subtraction. Or addition. Combine in a different fashion. Once again I am repeating this point. But only 5.84 grams as uncertainties in the subtraction or addition combined in a different fashion only. Now point number 3. The relative error of a value of number specified to significant figure significant figures depends not only on n, not only on n, but also on the number itself. Number itself. Now once again I am repeating this point, my dear students. The relative error of a value of number specified to significant figures depends not only on n but also the number itself. Now what is the meaning for that one? I would like to give an example so that you can easy to understand. Example, the measurement of mass is 1.02 grams, is plus or minus 0.01 grams. Now the relative error in 1.02 grams is the relative error is plus or minus 0.01 whole by 1.02 into 100. So that is equal plus or minus 1%. Now tell me, I would like to take another one. Another measurement Another measurement 9.89 grams is also 1 point is also accurate to 0.01 grams. Now therefore the relative error in 9.89 is that means the relative error is equal plus or minus 0.01 whole by 9.89 into 100%. So what we will get? Plus or minus 0.1%. Please observe carefully. Here 1%, here 0.1%. Here the number is 9.89. Here the number is 0.0. Here the number is 1.02. Accuracy is here the precision, here the precision, both are same. But even though here the relative error has been changed, from this one we understood that the relative error of a value of a number specified to significant figure depends not only the n but also not only depending upon n but also on the number itself, So on the number itself also the relative error has been changed. So from this one we understood. However, I hope you understood these 3 points. Thank you very much for watching this video. Thank you. Thank you.